here is we are given the point -5, -2, and we want to figure out how would that look translated if we translate that how? 2 to the right and 8 up. Remember, this is an ordered pair. So if we take a look at that ordered pair, we want to translate it, kind of if you plot it, see what it would become. Johnny, you're up first for this one. What do you think that's going to become? How would I figure that out?
You add 2 to 5 or 5.
Okay, so what would be the new x coordinate?
-3.
Okay, so if I started here, if I go 2 to the right, I do agree that that would be at -3. And then what about the y coordinate?
6.
Yep, because I'm going to go up 8 then, so my new ordered pair will be at -3, 6. So the biggest thing to remember that in an ordered pair, you kind of just do what you need to. Everyone has a review packet? Okay. All right, let's move on to number 2. Blake, you're going to help us out with number 2. If you have the point 3, 6, and I want to do the following translations. I want to reflect it over the x-axis and then vertically stretch it by a factor of 2. How am I going to do that?
So you're going to be working with the y value.
Okay, good.
So first, since you're flipping over the x-axis, you're going to make it a negative.
Okay, so what would my ordered pair be after my first
3,
translation?
-6.
Okay, so this one would be 3, -6. You just changed the y, and then what do I do next?
And when you're vertically stretching by a factor of 2, you multiply the 6 by 2.
Perfect. So again, it's the y change. You'll multiply it by 2, so what would your new ordered pair be?
3,
Perfect. So overall, your point is at 3, -12. So chapter 1, section 1 was all about using ordered pairs and just kind of doing exactly what it says. If it helps you to graph it and say, okay, it started at 3, 6, and then what happened? Okay, to flip over the x-axis, it's down here, and then to go from there about the vertical stretch. Let that help you when you do those, okay? Let's now move on to 1.2. So again, notice that they are labeled by section, so you can go back and see if you have some questions here. Callie Smith, starting off with 3a. What would be the parent function of that?
Okay.
So what would I write? What would be the equation of that?
F of x equals x squared.
Perfect. Now let's talk about transformations, Hallie. There's 2 things happening there. What do you think's going on?
Down 1.
Good.
And
So I'll kind of color code. So that down 1 came from this part. What happens with the negative in the parentheses?
Horizontal.
Would it help if I graph it for you?
Yeah.
Okay, so that's an option if you're stuck and don't know what to do. When I do this, I'm going to graph the original. So my parent function is x squared. And the new one I want to also graph is parenthesis, -x, close the parenthesis and square it, and then -1. So you already told us down 1. That's good. What about the -x? Whenever you see a negative, it's going to be a reflection. So which axis do you think this reflected over, the x-axis or the y-axis? The y-axis, because it's already symmetric. If it reflected over the x-axis, it would have been pointing down. So that is a reflection over, so reflect over y-axis. And again, a way to know which axis, it changes x, so it goes over the other axis. Let's take a look at B. So to help us out with B, Nick, we're coming over to you. What's our parent function for this one?
F of x equals square root of x.
Good. And again, in this one, Nick, you have 2 transformations to help us out with. What do you want to say the first one is?
Reflection across the x-axis.
So reflect across x-axis. I agree with that. Why is that? It's because it's out front. So it's right here. If you're out front, if you're changing y, well, then that means that you must be going over the other axis. So it's going over the x-axis. Well, what about the other one for this one, Nick? What's happening on the inside here?
To the left 3.
Perfect. Left 3. Again, if you want to verify that for transformations, graphing is a good option to help you out. I would graph both the parent function here, so I would graph square root of x, and I would also on the same page graph negative square root of x plus 3. The biggest thing to remember is you always start with the parent. So if I'm describing what happened, it went here and then it traveled this direction, so that's why it is left 3. and then you see that reflection over the x-axis. Questions on number 3, A or B? All right, we have one last thing that will finish up what we'll be talking about from 1.2. First thing is we need to do is plot the points. So take a second, please plot those points for yourself on your graph. And let's see what function this looks like. So 3, 8, 4, 1, 5, 0, 6, negative 1, 7, negative 8. So we want to graph it, connect it, and think about what parent function, what shape does that most closely resemble. Steve, this one's going to be coming over to you. When you're ready, let me know.
I'm ready.
Okay, what parent function does that look like?
F of x equals x cubed.
Perfect. My parent function is f of x equals x cubed. Now, when it goes to figure out what happened, you don't have an equation. So I think the easiest thing I would do is make the table of key values and plot that one to see what it looks like. Do we remember what the key values are for an x to the third? Steve, do you remember?
Sorry, I think
You do. So we're going to make our parent function our key values for f, bless you, f of x to the third. My x value I'm going to start with is negative 2, and I'm going to go negative 1, 0, 1, and 2. Steve, do you remember how to find the y's that go with that one?
you just plug it in.
Yeah, so just raise them each to the third. So negative 2 to the third, anybody, what's that going to be? Almost. Negative 8. What about negative 1 to the third? Negative 1, 0 to the third. 0, 1 to the third. 1 and 2 to the third. 8. Let's go ahead and plot that original one, the parent function, so we can see what has happened. So negative 2, negative 8. Negative 1, negative 1. 0, 0, 1, 1, 2, 8. And we're going to draw that in. And hopefully that will give us another aid to help figure out what transformations happened. So as a reminder, when we're talking about key values, if it's x, x squared, or x to the third, you always, in your table, your x's are always negative 2, negative 1, 0, 1, and 2. And then you use the power to figure out what the y's are. If you were talking about a square root function like Nick did before for us, the key values for a square root of x, well, that's going to be 0, 1, 4, 9, and 16. We want to use the perfect squares then instead. All right, let's go back up to here. We need to talk about transformations. If you look at the parent function, this is what numbers we should see. Those are the numbers we saw instead. So let's start with the x's. The x's are different. It should have been negative 2, but it's 3. It should have been negative 1, but it's 4. It should have been a 0, but it's at 5. 1 has moved to 6. 2 has moved to 7. Using your table, using the picture, what type of x change occurred in this function? Bella?
Shift left, right,
Start at the parent, go to the new.
right.
Shift right. So that's why graphing them will help. From the parent to the new. So shift right 5. And hopefully if you look at your x's and add 5 to the parent, it moves it to the new. What about my y change? Look at where y was and what happened. Sam? Not quite. Because if y changes, which axis do you go over? X. So my other change for my y is reflect over the x-axis. And that's because every y value is opposite of what it should have been. Other questions I can answer on 1, 2. Johnny. Sure. Again, we're trying to pull for you the key points from each section. So from 1, 1, that's the type of stuff you need to remember. From 1, 2, things like this. All right, we're moving to 1.3. We are given a function, a linear function. And the function of this is negative 4x plus 1. I want to take that function, move it down 3, and then horizontally stretch it by a factor of 2. Ashton, you're up first. How am I going to move that function down 3? So, is it
subtracted minus 3.
good, because was it an X change or a Y change?
It was a y change.
Good, so for a Y change, I'm going to take the entire function, negative 4x plus 1, and perform the change. Well, to go down 3, it's just minus 3. What did that clean up to be, Ashton?
4x minus 2.
Very close. Watch the sign in the beginning.
Oh, negative.
Negative 4x minus 2. That's after transformation number 1. You want to carry that through now to step 2. Ashton, I'm going to have you finish for us.
So it's an x change.
Good. For a horizontal stretch by 2.
So it's negative 4, and then in parentheses it's 1 half x,
Good.
and then minus 2.
So why did you make it 1/2 x?
Because it's opposite.
Anytime we have a horizontal stretch or compression, we need to use the reciprocal. We have to flip whatever factor we have. So what would that simplify to be for us, Ashton?
Negative 2x minus 2.
Perfect. That is your final function. That is g of x. Negative 2x minus 2. Okay, let's look at number 6. F of x is the linear function that is defined by the table given. Our first thing, part A, use the table to write a linear function f of x. Ben, you're up for this one. What's the format for a linear function? What form do I want my equation to be in?
Y equals mx plus 3.
You got it. That's a line. M stands for
Slope.
slope. What's the B?
Y intercept.
Okay. All right, Ben. How am I going to find my M, my slope, based on those ordered pairs? Want to phone a friend?
x2 minus x1 and y2 over y1.
Okay. Good, Sam, but flip those. So subtract y's on top, subtract x on bottom. It's rise over run. So if I subtract that, Ben, is that enough to get you back on track?
Yeah, I'll check that one.
Okay.
So
So are we okay? How about this first? Can you tell me what 3 ordered pairs this is from the table? Like what's one ordered pair from that table?
0, 9.
Okay, so one ordered pair is 0, 9. What's another one?
1 and 5.
Okay, and then
It's 5 minus 9.
what? Well, all right, 2, 1. But yes, okay. So it's making sure we know those ordered pairs. So what do you want to plug in now, Ben? 5 minus
5 minus 9.
good over.
1 minus 0.
Okay, so I think that's to give us negative 4 over 1. So my m value is negative 4. So in my equation, we know m. B is actually given to us in this one. Ben, you know which one is B? 9. It's always when x is 0, that B value is your y-intercept. So that's B. So my equation will be negative 4x plus 9. Better? Okay. All right, let's do part B. We want to take that function and we want to reflect it over the x-axis. So Sam, we're coming to you for that one. Is that going to be an x change or a y change?
So it's going to be a y change.
Okay, so what are you going to do to flip it over the x-axis?
I'm going to make it y is equal to 4x minus 9.
Good. Can you tell me how you got there?
Yes. So when you're flipping over the x-axis, you're reversing everything. So you take your negative 4x, positive 4x, and you have the positive line to make it negative.
Good. So take the whole equation and make it negative. So distribute that negative into both. Those are the skills you need to remember from 1.3. All right, let's look at 1.4 to finish up chapter 1. David, you're going to be up first here. When finding linear regression, remember, whenever you see the word regression, that means calculator found the equation for you. So when you use linear regression for a set of data points, the correlation coefficient is r equals negative 0.95. That's what your calculator told you. How would you describe that correlation coefficient? How would you describe the data? What could you conclude? There's 2 words I'm looking for. It's strong. That's one word. Tell me something about its sign. So you would say it's a strong negative correlation. So as a reminder, when I'm talking about correlation, your scale goes from -1 to +1. So obviously the word negative or positive is the sign of it. And the closer you work out towards 1 or -1, the stronger your correlation is. And if it's closer to 0 in the middle, then we describe it as a weaker correlation. Okay, so you're hoping for a strong correlation, that the data fits your equation very well. And number 8, our last one from chapter 1, we want to take this data, so it's the manager of a band kept track of the price of tickets and attendance. Use your Inspire to find a linear, keyword, regression that best fits this data. We have done linear regression, quadratic regression, cubic regression. We are pretty good with the skills. Read, circle, underline something so you know that you're clicking the right one. So to walk us through, Alec, you are up. How are we going to get the equation for this?
I'll look over to subtract.
Well, hold on. You want to use your calculator to do this, so we need to enter it in our calculator.
Oh, yeah.
So can you give me the steps how to do that?
Yeah, you should go to new document.
Okay.
Yes, spreadsheets.
Good.
And then go up to A.
Okay.
You get the price.
Okay.
And then you could fill in the price.
All right. So remember, I skipped on with the equal sign. So I'll fill in while you fill in. After I do that, Alec, I need your next step so we know what we're doing next there.
You could go to E.
Okay.
And fill in attendance. You can do it in the quarters.
Okay, so we're going to get all that filled in. Remember, if you don't want to write out the whole word, you can abbreviate with just PA. You can just call them X and Y. It doesn't really matter what you call them as long as you know what you labeled X and what you labeled Y. All right, Alec, when you are done entering, let me know when you're ready so we can do our next step.
Okay.
All right, what are we going to do to find the equation?
Control top.
Okay, so we're going to add a new page.
Then we're going to go to add data and statistics.
Okay.
Then we're going to click to add values.
What am I going to put on the bottom?
The X value, right?
Good,
And then on the left, we're going to put the attendance,
good.
the Y value,
And now, how do I get my equation?
menu,
Yep,
analyze,
good.
regression,
Uh-huh. What type do we want for this one?
we want a MX plus B.
Good. Linear mx plus b. So there's your equation that we need to write down. So if it gives you, it doesn't say to round, you should write all the decimals given. So y equals negative 20.9474x plus 368.895. All right, now for our follow-up. Now, before we do the follow-up, just as a FYI, I know some of you don't always use a data and statistics page, and that's okay. So you could have added a calculator page instead, and from here I could find the equation with menu, statistics, stat calculations, and then you can choose mx plus b or any of the others off this list as well. So you could say I called my x list price, my y list attendance, and there's your M value you'd plug in, there's your B value into MX plus B. Kiki.
Can you do that straight in those, like,
Yep, you could do it in a spreadsheet page too if you are okay with those little boxes. Ashton.
places?
Sure. All right, now we have our equation. So what we want to do now is we want to figure out what's the attendance when the price of a ticket is $9. So the biggest thing is making sure, did they give you X or did they give you Y? Hallie Wedler, do we know X or do we know Y? We know X, so we know that the price is 9. So how are you going to find the attendance for this one, Hallie?
Plug in that.
Okay, so walk me through what are you doing? How are you plugging it in?
So for the equation we just got,
Mm-hmm.
just write like the negative 20.947 parentheses 9 plus 368.895.
Okay. So are you just doing that on a calculator page? All right, so if you just plug that into a calculator page, can we have our number there? Can somebody let me know what we have? Blake? 181 equal, or don't round it down, 180. I would accept either of those. Any questions in chapter 1? Okay. Again, another option there is you could have graphed the equation and pulled up your table as well. All right, moving on to 2. All right, you're still recording. You're good. That's why I haven't chatted with or called on yet. There you go.
Okay, starting chapter 2, you're still working on, we went back to transformations, and we have to tell the difference between a horizontal and vertical transformation. So does someone want to give me a brief synopsis of the two and the difference? Jimmy?
It goes up 1.
Okay, so if this one goes up 1, how do I know that that's a vertical change and not a horizontal change? When I look at the equation, what is it not with, huh?
It's outside the parentheses.
It's outside the parentheses, so I know it's a vertical change, so I know my first one is going to be up 1. And then the second transformation, Jimmy, will stick with you.
Is horizontal stretch.
I agree with horizontal. I agree with the 1/5, but it's not a stretch because that 1/5 is less than 1. What am I going to call it? Compression. How did you know it was horizontal? Because it's inside the parentheses with the x, and whatever's inside the parentheses with the x, remember, we take the opposite of what we're thinking. So instead of multiplying by 5, I'm going to take 1/5 as what my factors would be. Any questions on number 9? Okay, number 10, the parent function is x squared, is horizontally stretched by a factor of 2 and reflected over the x-axis. Write the transformation for the function. Ryan?
So the 1/2 x squared first transformation.
So where's that 1/2 going to go?
The place for x.
Inside the parentheses or outside the parentheses? Inside the parentheses.
And it's reflected over the x. That's changing everything, so the negative.
Inside the parentheses or outside the parentheses? And if you're in doubt of whether it says you're reflecting over the x-axis, here's the x-axis, here's the y. If I plot a point here and I were reflected over the x-axis, the x-coordinate's going to stay the same, the y-coordinate's going to change. That's how I know it's a change in my y, or vertical transformation. Then here's your equation. Do you remember your vertex? Do you remember? Huh?
0, 0.
It's 0, 0. Everyone, the vertex form would be f of x is equal to a times x minus h squared plus k, where h, k is my vertex. So since I'm not subtracting anything from the x, I'm not adding or subtracting anything outside, then my vertex is going to be at 0, 0. Any questions on that one? Okay, the next one. Remember, we had a couple big ideas. You're expected to do this without your calculator. So the first thing we did is we have to decide whether this shape, what is this shape? Bella, what shape is this? Yeah, what's that called? It's a parabola. So the shape is going to be parabola. How can you tell if a parabola opens up or down?
Whether our number is negative or positive.
Okay, so if the lead coefficient is negative, it opens. If the lead coefficient is positive, it opens up. So in this case, I'm going to open down. Thank you. Next thing I'm going to do to sketch this, I'm going to find the vertex. And there was a formula that we learned to find the vertex. Tara, do you remember that formula? Anyone remember that formula? Go ahead, Alec. Yeah, we did negative b over 2a. And just to refresh you, that the a would be the negative 2, the b would be the positive 8, the c would be 3. So in this case, I'm going to do negative 8 over 2 times negative 2, and I get what? Alec, go ahead.
Yeah, -8 or -4, which reduces to
So what is that to? What part of the vertex? Okay, so it's the x-point of the vertex, so I know the x-point is 2. How would I go about finding my y?
C.
It's not C, sorry. C is up there, but
Plug it in.
plug it in. So I'm going to find f of 2. So I'm going to put 2 into the original equation. And that's going to give me the y coordinate of my vertex. Do you have that? What'd you get?
Um,
11. Good. That's 11. So my vertex is 2, 11. So I'm going to plot that point over 2, up 11. Not quite on the graph, but close enough. Axis of symmetry. Lauren, what does the axis of symmetry do? It divides the parabola in half. So it's going to be a line that divides the parabola in half. So what is the equation of that line that divides the parabola in half? X is equal to 2. And remember, if you don't have the x is equal to part, you're going to lose points because you have to show that it is an equation. Now, we have the y-intercept, Scott. What is the y-intercept? What? 3. The y-intercept is 3. And how did you get that? It's the C. So if this is 3, remember we found another point that we could graph. Do you remember that, how we would graph that other point? Okay, we've just said that this line cuts the parabola in half, so the left side looks exactly like the right side. So if I have this point here that's 2 units over, then I'm going to have another point 2 units over on the other side. And that we call the symmetry point, I think. I don't remember. You go. So I'm going to have my parabola that looks like that. And then using the same concept of finding the vertex of the parabola, we did some word problems. So in this case, we had the daily high temperature in Death Valley is modeled by T of D is equal to negative, you can read the equation, where T is the temperature in degrees Fahrenheit and D is the day of the year. On what day of the year was the temperature at a maximum? So this is a negative, the coefficient. So I know my parabola is going to open down. So I know that I'm going to have a maximum value. When I find this maximum value, that's going to tell me the hottest temperature in Death Valley. It's also going to tell me the day that occurs. So which one is which? Which one's the X and which one's the Y? And Kiki?
These are the days are X and then the points are Y.
Okay, so D would be the days, that should be the X, and then the temperature would be Y. How am I going to find the vertex of this parabola? Using the same formula I just used up there. Kiki?
The A, no, negative B over 2A.
I'm going to use negative B over 2A. So in this case, I'm going to do negative 0.657 over 2 times negative 0.0018. And when I do that, David, you have an answer? Are you working on it? What did you get? You get 182.5. So what, that 182.5 is what? The days or the temperature? Pardon me? It's the day. So what day of the year was the maximum temperature? You can say either 182 or 183. Either one of those would be acceptable because it's halfway in between. Now, how do I go about finding the maximum temperature? Ben? Mm-hmm.
You plug that in for D.
So I plug that in for D, so I'm gonna go ahead and do that. So I'm gonna do T of 100, and I'm gonna use 182.5. So you substitute that in every place you see a D. You do that? Did anyone do that? Blake, what'd you get?
I just put it in, or I would put it in, I didn't do it.
You didn't do it? Did anyone do it? Is anyone gonna do it?
I'll do it.
Okay, come on. Did you do it?
What are we doing?
You're putting 182.5 in for D to this equation. What'd you get, Hallie? 110.9, which is what? What's my units on that answer? Huh?
91 or 90
But what's the units? What is that, 110?
degrees.
Degrees. 110. So 13 and 14 are just a quick review. It says if the graph of the parabola opens up, so it's opening like this, will I have a max or a min in that parabola? Ryan?
It would be a minimum.
It would be a minimum. And then if the graph of the parabola opens down, will I have a max or a minimum? Scott? Max. Any questions on finding the vertex? Max or min? Okay, then in 2-3 we started solving equations by factoring. So the first way we learned to factor was to do what? Hallie Wedler. Product sum. So in this case, the product, in order to find the product, what are you going to multiply to find the product in this one? 3 and negative 5, so you're going to get negative 15, and your sum is 14. So now I'm looking for my factors of 15 that add up to 14. Steve? 15 and negative 1. So what do you do with the 15 and negative 1?
You write the equation as 3x squared plus 15x minus 1x minus 5.
And then what do you do?
Factor it out, so 3x squared and 15x.
And?
Negative x and negative 5.
And? So what can you factor out of the 3x squared? And
Oh, 3x
you're left with?
x plus 5.
Then what am I going to factor out of the last two?
Negative 1.
So that this factors as?
3x minus 1. 3x plus 5.
So that's the way it factors now. Oh, that's a 5. And now I want to find my zeros. How do I find my zeros? Sam?
Well, you,
These are technically both equal to 0 since I'm looking for my zeros. So what do I do with each parenthesis?
you'd, set it up, well, you start with 1, say, and we'll start with x plus 5, and subtract 5. So you'd be, x is equal to negative 5.
So my answer would be negative 5. And then this one, what do I do?
For x minus 1 equals 0, you'd add 1, so 3x equals 1, and then you divide by x, then you divide by 3, and that gives you 1 over 3.
So 1/3. And those are my two zeros, and that's how I factor. On the final exam, make sure you pay attention to the directions as to how we ask you to solve for zeros, because you learn many ways. You learn factoring, completing the square, quadratic formula, so make sure you follow the directions to do what you're being asked. Okay, writing a quadratic equation in standard form with that has the zeros of negative 2 and positive 3. Blake, what's the first step that you would do?
Well, you could write the, in parentheses.
Yes.
You could like do the product sum backwards.
Okay, so what would I do?
You'd put, x plus 2 and in parentheses, and x minus 3.
X minus 3. So those are going to be my factors, and then how would it
Multiply.
multiply them? So I'm going to foil.
Foil
So
them, yeah.
so when you foil them, what do you get?
We foil them. You get x squared minus 3x plus x squared. Oh wait, no.
I'm gonna multiply the inner
Plus
two now.
2x. Minus 6.
Minus 6, then I'm gonna combine my like terms, so these two in the middle should be my like terms. And I end up with,
Negative x.
my final answer is x squared minus x minus 6.
Yes.
Any questions on 2, 3? Okay, now I have an equation where I have a word problem. I have an object that's modeled, the following of an object is modeling by the equation h of t is equal to negative 16t squared plus h sub 0, where h of t gives the height at any time t, and h of 0 is the initial height of the object. A hammer falls from the top of a 130-foot building. So the first thing I have to do is write a model that's going to model this situation. Ashton, what do I do?
You do h of t, so h plus t equals negative 16 t squared plus 130.
Plus 130. All I'm doing is substituting in my initial height for the h sub 0. Then it says, how high is the hammer above the ground after 1 second? What would I do then?
Would you plug in 1 for t?
So I'm going to plug in 1. So I'm going to find h at 1 second, the height at 1 second. So I'm going to have negative 16 times 1 squared plus 130. Technically, I have to square the 1 first before I multiply it by 16, but 1 squared is 1, so it doesn't really matter, but just in case. And what do I get?
1.t.
And what's your units on that?
Seconds.
Feet. It's my height, so that's going to be feet. So after 1 second, my hammer is 114 feet off the ground. The second part says use a model to find out how long it'll take for the hammer to hit the ground. Now what do you do?
You set the equation to 0.
Yeah, so I'm going to go back to this original equation, and I want my height to be 0, so we'll put 0 there. Then how do you solve this?
You subtract 130 on both sides.
Okay, keep going.
And then you divide by negative 16. And then you get t squared equals 8.125. Then you square root of both sides. You get t equals 2.85.
2.85. Technically, it would have been plus or minus 2.85, but you're only looking at the positive one. So it's going to be 2.85, and what is your units on that one?
Seconds.
Seconds. So that hammer is going to take 2.85 seconds to hit the ground. Any questions on that one? Okay, solve by completing the square. Again, this is where you have to follow the directions and solve the way we want you to solve. So this one is completing the square. When you complete the square, does anyone remember what that is? Anyone at all? No one. No. That's where you make it a binomial squared instead equal to something else. So I'm going to try and make the left side a perfect binomial, something squared, a quantity squared, and the right side will have everything else. So before I start completing the square, the first thing I want to do is I want to factor out any greatest common factors. What is the greatest common factor?
3.
3. But I'm actually going to factor out negative 3, so I'll make my lead coefficient positive. So I'm dividing everything by negative 3. I'm even dividing the 0 by negative 3, which will still be 0. That's why I can do that. So you have x squared, negative 2x, minus 3 is equal to 0. To make it easier on myself when I complete the square, I like to take any constants and put them on the other side. So I'm going to have x squared minus 2x, and I'm going to have that 3 on the other side. Kind of gets it out of the way. Then similar to finding the vertex, I am going to take this middle term. So I'm going to take that negative 2, and I am going to divide it by 2, and I'm going to write squared. So negative 2 squared is negative 1 squared. Negative 1 squared is 1. So that tells me what number I'm going to add to both sides. I'm going to put a 1 here. Add 1 to the left side. If I add 1 to the left side, what do I have to add to the right side? 1. So I'm going to add 1 here. I'm going to rewrite this as x minus 1 squared. That minus 1 will match that number that I have there. If I took x minus 1 and multiplied it, x minus 1 times x minus 1, what would I end up with? Lauren?
Minus 1x minus
Plus 1. So that would be x squared minus 2x plus 1, which is what I have here. That's what I've done, is I've just rewritten this in this form. That's all I've done. And then 3 plus 1 is 4. So now I'm going to complete the square, so I'm going to take the square root of both sides. When I do that, I take the square root of something squared. What do you end up with, Johnny? Not squared. So whatever it is, not squared. So this will just be x minus 1. And the square root of 4 is? It's 2 and? Negative 2. So you're going to have to write plus or minus 2. Can I move this one? Oh, good, I can. So now I have x minus 1 is equal to a positive 2, and I have x minus 1 is equal to a negative 2. I have two separate ones that I have to solve for. When it's equal to a positive 2, I'm going to add 1 to both sides and get x is equal to 3. Add 1 to both sides, x is equal to negative 1. So my solutions are 3 and negative 1. Okay, then identify the vertex form and I'm sorry, I read that wrong. Write in vertex form and identify the vertex. We're going to actually do this one backwards. We're going to find the vertex first, and then we're going to write it in vertex form. So how do I find the vertex of this? We've done this before. How do I find the vertex? Bella.
negative b over 2a.
Negative b over 2a, sticking with that. So in this case, I'm going to do what?
8 over 2 times 2, which is 2.
Which is 2. So the x coordinate of my vertex is 2. How do I find my y coordinate?
Plug 2 in where there's an x.
I'm going to find after 2, the 2 times 2 squared, and 8 times 2 plus 4, and you get
Negative 4.
negative 4. So that's my vertex. Then I'm going to go back and remember that the formula for vertex is f of x is equal to a times x minus h squared plus k. This vertex is my h and my k. What is my a in this case? Scott? 2. It's the lead coefficient, so this is my a. So knowing that information, can you write the equation in vertex form?
2 squared plus negative 4.
Plus negative 4, so I'm going to write minus 4. Much easier way of doing it. Yes? Any questions on that one? Okay, then 2.5, we introduced taking the square root of a negative number. In order to get rid of that negative, well, not get rid of it, in order to handle the negative sign underneath the square root, Nick, what did we said the square root of negative 1 was equal to what? Nick? Okay, so anytime I see a negative sign like this one, when I go to simplify it, here's that negative 3 that's out. Because that negative sign, I'm going to think of it as I, and then the square root of 16. And what is the square root of 16 then?
4.
4. So this will be negative 3i times 4, which I will write how?
4 times negative 3i,
And what is 4 times negative 3i?
7i, negative 7.
4 times.
Oh, negative 12i.
Negative 12i. So the next one, I have this negative sign, I'm going to leave that negative sign. Take care of the negative sign inside the radical, I'm going to write an I. So now I have negative I times the square root of 50. 50 is not a perfect square, but I can simplify it. There are perfect squares inside there. So that's where I take 50. And how can I factor 50? 2 and 25. Are there any perfect squares in 2 or 25?
2 is a perfect square and 25 is 5 and 5.
Well, 2, square root of 2 I'm going to leave as the square root of 2, but the square root of 25 is 5. So 50 can be rewritten as 5 times the square root of 2.
So it'd be negative I.
So it'd be negative, what's 5 times I? 5i times the square root of 2.
Yeah, wait a minute.
Isn't negative I just negative negative?
Yeah, when it becomes.
No, this negative sign is from that negative. That's where that negative sign comes from. I comes from the negative sign being underneath the radical. So you have to think of I as like a variable. So if I have a negative times a variable, I just leave it negative the variable. So, all right, for number C, I have 4 times the square root of negative 300. Steve?
You take, try to see what,
Okay. But how would you first start factoring 300? What's the easiest way? 10 times?
30.
Okay, you're going to make us work for it. All right, how would you factor 10? 5 and 2. Those two are both prime numbers, right? So I'm done. How would I factor 30? 10 and 3. How would I factor 10? 5 and 2. And then 3 is a prime number, right? So here are all my, I'm going to circle all my, the numbers that I have to multiply to get back up to 300, right? Anytime that I have 2, so I have a 5 here and a 5 here, anytime I have 2, I can pull 1 out. Does that make sense? So I'm going to have a 5 outside the radical sign. I also have another pair. I have 2 and 2, so I'm going to pull those out of the radical. So I'm going to have times 2. And then I have this 3 that doesn't have anything, so that he stays underneath. So I have 5 times 2, which is 10, times the square root of 3. But there's one thing I forgot. So this, what about this negative sign? So I have 4i times 10 times the square root of 3. What do I get when I multiply all those together? Blake?
40i times the square root of 3.
40i times the square root of 3. So as soon as you see that negative sign underneath the radical, just pull an I out. Does that make sense? Okay, then we had find a complex conjugate. When you learn this, you learn that each number has a real part, which comes first, and the imaginary part, which comes second. When you find a conjugate, it's important that you put them in the order, real, then imaginary. So the conjugate would be the real number stays the same, and then what happens to the imaginary part? Sam, do you remember?
Doesn't it become negative?
It changes signs. So right now it's a positive 5, so I would make it a negative 5. You have 2 minus 5i. Now, Jimmy, when I go to do the next one, negative 4i plus 9, I should probably rewrite that before I start. How should I rewrite that?
9 minus 4i.
Right now, it's 9 minus 4i, so when I find the conjugate, it's going to be
9 plus 4i.
9 plus 4i. Take the time to write that with the real part and then the imaginary part. That way you won't mess it up. Okay, now I have 5 minus 7i. Johnny, first I'm going to rewrite it, so how would I rewrite it?
7 minus 5i.
Well, right now, the 7 is what kind of number, positive or negative? So -7, and the 5i right now is what kind of number? Positive. Now, when I go to do the conjugate, what's it going to be?
-2.
Say that again?
Or -7 minus 1.
-7 minus 5i. Take the time to write the real, then the imaginary, especially when you have a lot of negatives in there. Okay, now it wants us to find the zeros by completing the square. So we've done this once, so we should be good, right? Hallie, good? Smith? What would you do first?
So set the whole thing equal to 0.
Set the whole thing equal to 0. Then what?
And then divide each by 2.
Divide everything by 2. Keep going, you're doing well.
And then you would move the 20 to the other side.
So I'm moving this 20 to the other side, so I'm adding 20 to both sides.
And then you would find the square root.
Well, you're going to look at your middle term, which is -6, right?
Yeah, and then divide it by 2.
How did 40 become -20?
Because I divide, oh, it should be, oh, you're right. That should have been positive 20.
It's a positive.
Oh, nice, fine, thank you.
Oh, yeah.
So then that equals -3 squared. And then that is 9.
So what do I do with that 9?
You take the 9 and you plug it in the right side, so you do +9. And then
If I add 9 to the right side, what do I have to,
add 9 to the other side. So it becomes 11.
-11? Okay.
And then
And then this I'm going to write as what? I'm gonna-
x minus 3.
X minus 3 squared. That -3 is this number that I got here. Does that make sense? Are you still good? You want to keep on going?
Okay.
Okay.
You take the square root on each side. So it becomes negative the square root of -11.
So this will be plus or minus,
This will be plus or minus the square root of 11.
but because it's negative, what am I going to put out front?
I.
I.
And then equals x minus 3.
X minus 3.
And then you subtract your, add 3 to both sides.
I'm going to add 3 to both sides. So I'll have 3 plus or minus I times the square root of 11 is equal to x. And those are my two answers. One is 3 plus I times the square root of 11. The other one's 3 minus I times the square root of 11. Sam?
No, I forget the difference between this formula and the vertex formula.
The vertex formula is when you're finding the top of the parabola. So I could have, not really. I could have, if I wanted the vertex of this parabola, then if I put this in vertex form, I would have taken this 11 and it would be back over here. And the vertex would be -3, 11. But there's a difference between doing the vertex form, you're looking for a max or a min, or you're looking for the vertex, which means that you're going to want to keep the equation set equal to 0. This one, you're trying to solve it. So that's why you want to have the variable on one side and everything else on the other side. See the difference? When I do vertex form, I want to keep everything on one side. When I'm solving, I want to keep my variable on one side, everything else on the other side. Make sense? Okay. And I think that's it for my part. Oh, yes, I'll continue. Okay, now we're going to do quadratic formula. And who remembers the quadratic formula? Bella?
-3 plus or minus the square root of b squared minus 4 times a times c over 2a.
So that's the quadratic formula. And so then I know that my A, my B, and my C, yes? So then when I substitute in, what do I get, Lauren?
Plus or minus the square root of -2 squared minus
I'm gonna write 2 times 2 if you don't mind. So someone will ask me how you got 4. Most important part is that I have this -2. I put that in parentheses, especially if I'm finding it using my calculator, because if I don't, I will get the wrong answer. So somebody, please, just do what's inside the radical and give. You can put this all in your calculator in one step and get an answer for that. Did anyone do that? Anyone at all? What?
Get the answer in decimal form.
I don't want decimal. I'm sorry.
Could you divide everything?
I cannot divide everything by 2. And the reason why I can't divide everything by 2 is because I cannot simplify, because this is technically raised, what's underneath the radical is technically raised to a different power, so I cannot simplify if they're not raised to the same power. Ben?
It's 12.
You should get 12. So I'm going to have 2 plus or minus the square root of 12 all over 4. Again, I cannot simplify by 2 here either because that 12 is still underneath the radical. But I can simplify the square root of 12. So I'm going to say the square root of 12 factors as
6 and 2.
6 and 2. Make me work for it. And then 6 is
2 and 3.
2 and 3. So when I rewrite the square root of 12, it's going to be, these two are the same, right? So they come out square root of 3. So 2 squares of 3. So now I'm going to have them going over here. 2 plus or minus 2 times the square root of 3 all over 2. Now that I have everything out of the, now I can simplify this 2, and this 2.
Yeah, why isn't it 4?
Oh, it was 4. I already divided. Oh, see, I should have stopped. There's 4. Now I can divide everything by 2 and get, this will be what? 1 plus or minus, this will be 1, but I'll have the square root of 3. It's all over 2. That's what I did. I already divided by 2.
All right, here we go. So let's keep going. We're on 24. And we have another one with quadratic formula. Callie Wedler, you're up. What do I need to do to solve this with quadratic formula?
Move the negative 4x over.
Okay, so Callie's telling us what to do. We're going to move the negative 4x over, so we're going to add it over. So what is your equation going to be in standard form, Hallie?
Negative 4.
Oh, okay. So give me one step before that. So what actually, when you move the 4x over, what's that equation?
Oh, 3x squared plus 4x plus 8.
Okay, and equals what number?
0.
0. So if you're giving yourself some helpful hints here to study, when you see the word solve, that always means get one side of the equation equal to 0. That's how we always start off. All right, Hallie, now what is your A, B, and C, and then you can start plugging in.
3 is A,
Okay?
4 is B,
C is?
3.
Okay, so when we plug into quadratic formula, Hallie, go on. What are we going to start off with? X equals?
Negative 4 plus or minus square root of 4 squared
Good.
minus 4 parentheses 3 parentheses 3 over 2.
All right, so again, unless it is a word problem and it asks for a decimal, you want to set it up, and then you just want to use your calculator just to figure out what number is under the square root. So if you need your calculator for that part, again, I put the B in parentheses because if it's a negative, for sure you want to make sure you get that as a positive number. Blake, what number did you get for that?
I got negative 20, so it would be I the square root of 20.
All right, so you are a step ahead of us, but you are correct. So he ended up with negative 20 under his radical. Since it's a negative, he notices that he's going to need to make that an imaginary. So this would become negative 4 plus or minus I square root of 20 over 6. As Mrs. Ward told you, you may not divide into that 20. You have to first go and reduce that 20 kind of off to the side.
Wait a minute, where'd you get the negative 4 from?
The opposite of B.
Oh, it's opposite of B on the outside?
Yep.
Okay.
Hallie, back to you. How are we going to reduce square root of 20? Find me a perfect square that goes into 20, because 20 itself is not a perfect square. Okay, I don't disagree with 10 and 2, alright, but you're going to keep breaking them down. So my preference is to find a perfect square times some other number. If you want to do like a factor tree, you can go that way too. Yeah, I think that's a kind of quicker way to see what you're doing. You're not wrong there. So if you say 4 and 5, what's the square root of 4, Hallie? 2. So remember, when you go to rewrite that, there's an I also. So when we write this, we need to remember that I have to include this I when I rewrite this whole answer. So that part becomes 2I square roots of 5. So this part will look like negative 4 plus or minus 2I square roots of 5 over 6. Not including the radical, what do those three numbers have in common that we could all divide them by? 2. So my reduced answer for x should be negative 2, because I divide 4 by 2, plus or minus 1I square roots of 5 all over 3.
Can we just write I and do that to 1I?
Sure, you can just put I if you'd like instead of 1I. Those are your two answers. What kind of answers are those? If it has an I, they are imaginary. Would you see those answers on the x-axis if you were to graph that function? No, because imaginary answers you can't see where it crosses. It doesn't actually cross. Which, that kind of leads us into 25, which is why I asked you that one. So, if I want to talk about the discriminant of a quadratic function and sketch a graph that matches this, the discriminant tells us lots about this. Lauren, you're up. Do you remember what the discriminant is?
It's the part under the radical.
Okay, and what part, we go back to our formula, which I'm guessing is somewhere up here. There we go. What part was under the radical?
B squared minus 4AC.
Okay, so that's my discriminant. B squared minus 4AC. If we just looked at that part of the quadratic formula and we figured out, is it greater than 0, so is it a positive number? Is it equal to 0? Or is it less than 0, a negative? So that means under your square root, if you had a positive number, or if under your square root you just had 0, or if under the square root you had a negative, that was enough to at least predict what kind of answers you would get if you were to keep solving. So if we had a positive, Lauren, do you remember what kind of zeros and how many? You got it. So if it was a positive, 2 real answers. What if it was equal to 0? It's real. How many real? Sam? 1. And what if it was negative? How many, Bella?
2.
What type?
Imaginary.
Okay. To sketch a graph, this was directly from the front page of your 2629 test. We want to draw a picture. All of these are quadratics. What shape does a quadratic function have? A parabola. These all must be used. If you're drawing something besides a U, you're not drawing a quadratic. So in the first one, it has 2 real zeros, which means pick any 2 points on the x-axis. They can be on the same side of the y-axis. They can be 1 on each side. Your choice. You may draw a U that either opens up and crosses through them or opens down and crosses through them. Again, both of those zeros could have been on the left, both could have been on the right, one of each, your choice. 2 places it crosses, a U that goes through it, either opening up or down. If it is one real solution, well, it's going to cross our x-axis at one point, and we're going to make a U that touches that. Again, it may open up, it may open down. That point may be anywhere on the x-axis. So it's not going to cross through because it can't come back up, which means I'm going to draw mine opening down. Why not? It should like bounce off of that point. Okay, we've talked about cross and bounce. What if it's too imaginary? Blake?
Then it doesn't touch the x-axis.
Right, so make a U going up, but so it doesn't touch this, so maybe like this. It can touch the Y, just not the X. Or make a U going down, but again, it cannot touch the x-axis. So you could draw one of those. Don't draw both of those graphs. One of them would be correct. All right, that finishes 2-6. So if you're making a little, note card or something to study from, formulas you need to know so far, how to find a vertex, negative b over 2a, if you have standard form, quadratic formula. Okay, those are 2 formulas so far we need to make sure we know how to do.
Are we allowed to have it on the test with us?
You may not, but just as a study aid if you're kind of organizing your thoughts. Okay? All right, number 26. We're moving on to 2-7. I want to graph this inequality. Y is greater than negative 2x squared plus 2x minus 4. Now, you just graphed a quadratic with Mrs. Ward, but this one is an inequality. There's two things that make it different when you graph an inequality. What's one of them that's different? Bella, what's one?
You have to shade.
You're going to have to shade. Ashley, what's another?
You have to know if the line is solid or dotted.
Solid or dotted. Okay. Blake, do you know if this one will be solid or
To
dotted?
be dotted,
Why?
because it's not all equal to.
Perfect. So if you're giving yourself some notes, if it's less than or greater than, we'll say we'll have a dotted line, or you call it a dashed line when you draw this in. If it's greater than or equal to, less than or equal to, those will have a solid line. So this one will be a dashed line. And when I go to shade, because it's y is greater than, once we find our vertex, we'll shade greater than the vertex, above the vertex. We have our calculator, so why don't we have our calculator help us see what the picture looks like? We're not going to do the inequality part, we're just going to graph it like a normal equation. So on a graph page, let's graph negative 2x squared plus 2x plus, what's my other number here? Plus 4? Plus 4. So based on our picture, does my graph open up or down?
Down.
Down. Are we all okay with that? Hopefully yes. Johnny, if I want to find the vertex, how am I going to do that?
Control menu.
Okay, so we're going to go to, I think just menu, not control menu.
Analyze.
Okay, so I'm good with this method. All right.
And then maximum,
Why are you choosing maximum and not minimum?
because since it opens down, the maximum has to be on top.
Yeah, it has a high point. So one method to find the vertex, you can do negative b over 2a and plug back in. But if you have your calculator also, that is considered a maximum. That vertex is the maximum. And you need to know this skill anyway, so we can do the maximum. Remember when it asks you lower bound? Well, there's my vertex I'm looking for, so I'm going to click to the left of it and then to the right of it. Because I'm not actually looking for a max, I just used that for my vertex. The vertex is that whole ordered pair. 0.5, comma 4.5. So we know it opens down. We know the vertex is the ordered pair 0.5, comma 4.5, so we can put that on our graph. Johnny, how am I going to find my y-intercept, or what is my y-intercept?
4.
4. How do you know that? It's the c value, correct? Or it's the point 0, comma something, and we can see it crosses at 4. So your y-intercept is 4. So you can write it just as 4 or as the ordered pair. I want to make an accurate graph. I do not want you just to eyeball it and draw it in. How can I get more points to plot? Ben?
By putting control key.
Perfect. So let's plot a couple of those together. We're going to plot some points here. Let's clear this out so we can see what we're doing. So again, I want to just plot the ones that will fit. So negative 2, negative 8, negative 1, 0. We already have 0, 4. Now we'll have 1, 4, and 2, 0. So take a second, plot a couple of those. And again, you can use that idea of symmetry to help you figure out where the other ones will be. Again, we said this is different in two ways from a regular quadratic function. An inequality has solid or dashed lines and shading. So we already decided it's going to be a solid line. So I'm going to put a solid line on the outline of this parabola. And when we shade, we're going to go to the vertex. Okay, so we'll go to the vertex here. And because it is greater, y is greater, we'll go to the vertex and shade up. Well, in that case, that means we'll be shading on the outside of our parabola. All right, questions on that one? All right, you are flipping the page and we're looking at number 27. So we have 2 questions left to finish us up with 2.7 today. In 27, we want to solve the inequality by using algebra. Okay, so again, Mrs. Ward said, take a look at the keywords so you know how to solve. You have to use algebra to solve this inequality. And I'm going to write my answer in interval notation. So if you think back to 2.7, this was the one where it was the back side of the quiz on the top. You had to make a number line, do your test points, see what worked, what didn't work. That's what we're talking about here. So, first thing, if you look at our equation, David, my inequality is x squared minus 5x plus 12 is greater than 6. How am I going to start to solve that with algebra, David? Yes, because anytime you want to solve, one side has to equal 0. All right, so we'll subtract 6. I'll have x squared minus 5x plus 6 is greater than 0. So we have our 0. Now we can work with the other side. David, what method do you think we might use to solve x squared minus 5x plus 6? You got it, David. What's your product? What's your sum? Okay. What multiplies to 6 but adds to negative 5? Okay, I agree that that part would get you negative 5, but that's going to multiply to negative 6. So what's another option? Negative 3, negative 2. Okay. When we go to factor, again, we like to split the middle term into negative 3x minus 2x. We bring down the beginning, we bring down the end. If I factor out what's in common, I get x minus 3 left over in the first one. If I factor out what's in common for the next part, again, I get x minus 3. So x minus 3 and x minus 2. David, how will I figure out what two numbers I actually want to use for my test or my critical numbers? Perfect. I'm going to set each of these equal to 0. So it looks like my numbers I'll use to test around are 3 and 2. Questions to that point? Okay, because it's not just solve an equation, it's an inequality, we need to make our number line. We're going to test around 2 and around 3. All right, Nick, give me a number you want to test that would be to the left of 2. All right, so I'm going to test x as 1. What about between 2 and 3? All right, test, we're going to test 2.5. And what about a number bigger than 3? Okay, test 4. Here's the biggest mistake that we had in 2.7. When you go to test them, right here what I have highlighted, this is the one I'm going to test it because it already has 0 on one side. I think that's the easiest place to test that. And you're going to hope that if you plug in the x value, you want to know, is that answer you get greater than or equal to 0? If you want to go back and test up here and compare it to 6, that would work also. But sometimes when there's x's over there, we would get a little confused on how to do that. So I always like to do it when it's equal to 0. So if I plug in 1, I want to know, is 1 squared minus 5 times 1 plus 6, is that greater than 0? And if I plug in 2.5 for x, is that answer greater than 0? And if I plug in 4 for x, is that answer greater than 0? And remember, there always should be a pattern. Either yes, no, yes, or no, yes, no. Okay? So if we test these, and we want to figure out which of these would work, hopefully you're going to verify with me, but I think this one should be a yes, this one should be a no, this one should be a yes. Which means I would use this piece is good, that's a no, and this piece is good. So my answer in interval notation would include this part of the number line and this part of the number line. Does anyone remember how to write that in interval notation to finish up this problem? Alec? Okay, swap those around. So negative infinity to 2, which one's the smallest to largest. Your infinity always have parentheses. Do you remember if 2 will have a parenthesis or a bracket? You're right. Why? Look at your symbol. Do they have an equal to?
No.
No. So with an equal to, that's a bracket. Without one, it's a parenthesis. That would be this part of your answer, Alec. How are you going to tell me this part of the answer? 3 to infinity. So we would say union 3 to infinity. So this would be my answer in interval notation. If it was just the inside part, we would have said parenthesis 2, comma 3 parenthesis. Okay, let's try to power through and do this one last question because it's mostly a graphing one. You can do it. We need your calculators out. I have a consultant who has a beauty salon. Their profit is given by that equation. X is their average cost. What range of costs will bring in at least $48,000? So if I set this up, I want their equation to be at least $48,000. What inequality do I want to use to say I want my profit to be at least $48,000? Jimmy? All right. It does not say to solve algebraically, so can we graph that first equation? So on a graph page, we're going to graph negative 50x squared plus 3500x minus 2500. And I don't care what the picture looks like, I want to look at the table. Control T. If they charge, remember the X value here is their cost that a customer's charge. Well, if they charge $1, are they going to meet what they want to get for profit? No, it's only at $950. So you want to go and find the first X that gets you to that value. And it looks like $21 would be the first time that they hit that profit mark. So we know that they want to charge starting at $21, a bracket because we had an equal to. But you need to see what's going to be the cap on that number. So we want to find what's the highest value we can do before I drop under that 48,000. So it'll go higher, and then it'll start to come back down. I'm just tabbing down on my table, and it looks like if they go to 50, they're under where they want to be. So $49 would be where they have to stop for their profit. So it'd be from $21 to $49.